So we're going to do vector addition. And also, hopefully, we get time making vector subtraction at the same time. Okay. So when we were talking about yesterday, just looking at vector and scalar quantities, there was one part on the video which we remember that if I had a shapes, come on, the shapes aren't. Oh, there they are. Just get on there. So if I have a shape like that, okay, and I ask, say, Monica, is it? Yep. Monica, if you can push over here, here's Monica. So pushing hand, okay. And I want her to help me push this block, okay. Well, let's pretend we're back in ancient Egypt. So there's an Egyptian, you can be Cleopatra actually. Okay, let's put some pyramids in the background. Okay, sorry. Rightio. Now we need to push this block, and you and a whole group of your own slaves are going to push at 100 newtons this direction. So here we are, we're pushing that way, and I'm going to give you a hand, even though I'm Pharaoh. I'm going to be over here as well. So let's push me over here with a headdress and little staffy thing up there. There's me. There's a... No, I'm not noses, letting my people go out together. Okay? And some stripey apparently. Okay, and I'm going to pull along here, and I'm Pharaoh, I don't have to pull at 100 newtons. I'm going to pull at maybe, let's say, 20 newtons as well. Okay? Are we pulling in the same direction? So what's the overall pull in that direction? 120. 120 newtons makes sense, doesn't it? Okay. What happens if, of course, you know, Pharaoh, in his wisdom and his largesse, decides that he's not going to pull and actually goes and pushes against, just to be annoying, because that's what us royalty do. Okay. What would the overall force this direction towards the, what's that, right? What would the overall force? Now, Mon, you're pushing with your what? How much are you pushing? And you're going to slaves? 100, okay. What am I pushing against? 20. Now, her slaves are much more powerful than me, only in, you know, pushing this. Obviously, I'm more powerful in Egypt. I'm Pharaoh. But what's the overall this time? 80. Okay. 80 newtons. Okay, so forces do add together, but forces are vectors. They add and subtract. But do they always just add and subtract so easily? And the answer is, unfortunately, no. The only time they add so easily is if they are in the same direction or in the exact opposite direction when they subtract. So let's have a look at what goes on with it. Now let's just see if I can get this working. And there. Ooh, okay. And I've got to push there. Yay. Now, are you happy that is that pause? Yes, excellent. Are you happy that that actually is a true statement? Does 2 plus 3 equals 5? Okay. What happens if I were to put kilograms in here? Is 2 kilograms plus 3 kilograms 5 kilograms? Yes. The reason being is they are scalar values. Okay? If you have scalar values, then it adds always the same way as our numbering system works. So even if we keep on going, come on, keep on going, and they became seconds, 2 seconds plus 5 seconds is, 3 seconds is 5 seconds. Okay? So it works. Okay? It doesn't matter what goes in there, if there's scalar values, they always work. But let's have a look at this situation. I live at home here. Okay, it's my home, and I'm going to travel 8 kilometres, and I'm going to rub my compass rose. found someone on YouTube, east. Okay? I'm going to walk that direction. And now I decide, after 8 kilometres, after the big walk, I'm going to travel 6 kilometres north. Are we okay with my journey? 8 kilometres east and 6 kilometres north. Okay. My question is, how far and where am I? Now, I chose these numbers because they form that beautiful Pythagorean triangle that you first came about in year 9 or 8, whenever you did Pythagoras. So that's 10. You just use Pythagoras. You don't need to prove that, do you? Okay. So that's 10, the hypotenuse. Okay. That's because that's a 90-degree angle. You're okay, that's 90. Okay. So let's have a look at it. What's my distance? My distance is how much, Robert, what's the definition of distance? How far you simply travel. That's it. There's nothing more than just to travel. Okay? So I've travelled 8 kilometres and then 6 kilometres. So I'm travelling distance of 14 kilometres. Woohoo! But my displacement is not the same as distance. Displacement is defined not as how far I've travelled, but where am I in reference to my starting point. Okay, that's the definition of displacement. Displacement is how far I have moved all up. Where do I end up? Well, that we know is 10 kilometres. But now I'm going to describe where I am in terms of angles. And 36 degrees. How do I get 36? I had to use trigonometry. Okay, just believe me for a few moments. I'm not going to try and do trigonometry at the moment. So it's 36 degrees. That angle down there was 36 degrees. And it's 36 degrees north from the east, or in better, it's actually north 54 degrees east. Are we okay with that? So are we okay with the difference between displacement and distance? Now, have a look at that triangle there. That means that we should be able to use that triangle and say, okay, how do I add 2 vectors? This is a vector because I firstly displaced myself 8 kilometres east, didn't I? I walked 8 kilometres east. That was my first displacement. Then I walked, how am I going to do this? 6 kilometres north, okay? So I did 1 displacement, 2 displacements. And then the final displacement was this long brown arrow here. So this final displacement is equal to 2 smaller displacements. Are we okay with that? Look how we added them. We drew the 2 arrows, and notice I made like a little bit of a journey diagram. And then I said, okay, here's my starting point. I draw the arrow to the end of the starting point. From start to finish. Okay, are we okay with that? So, this is just reminding us that distance is a direction from the reference point. I forgot that was coming up. And there's the total distance travelled. So that's that. Come on, going. I don't put too much time on that one. Okay. Now, I want you to imagine you've got, why do we need to be able to add vectors together? Which, unlike Pharaoh and Mon a few moments ago, we need to, because that was easy. What happens if I'm going to do this? Imagine that this ball is going to be kicked or hit by 2 forces. One pushing at a 5 Newton force this direction with that arrow, and one is a 7 Newton force in that direction. Which way will the ball go? Will it go directly straight in the centre? Will it do that? Or will it do that? Or will it do any combination of those? We want to know which way. Science needs to formulate a prediction of what's going to happen. We don't want to just say, okay, let's just do it and see which way it goes, and from now on that will happen. So what we're going to do is we're going to add these 2 vectors together, because we know that if Pharaoh and Monica push together, their vectors add together. Okay? But how are we going to add vectors when they're not in the same direction? So it's quite a simple thing to do. We firstly decide which of these vectors is going to be our original vector. Okay? So you just choose one. We don't care. Let's just choose the 7 Newton because it knows it moved just a few moments up into position. Okay? Now I'm going to move the 5 Newton vector to its end. Wind yourself back at that picture of the diagram of the house. Okay? We put the 2 arrows end to end. So here's my first vector. I just move the other. I don't twist it. I don't make it longer. I just move it over to here. Okay, happy with that? We just put the 2 arrows end to end. Now, the last thing we did is these 2 will now add, and to work out which direction they actually add to, we're going to draw another final vector from where to where? From the start to the finish. Be careful, it's always got to go from start to finish. Don't go finish to start, that's going backward. So we're now going to draw a final arrow. There's our start, there's our end. Now we draw a final arrow which points from start to finish. That is the final force. That's what will happen if you add these 2 vectors together. So this vector plus this vector gives you that vector. Okay, happy with that? Now how can I find the length of that vector? Oh, yes, it's cosine rule, sine rule, all those trig rules. Yeah, going to get used. And the angle, trigonometry as well. Apart from that, of course, if you just draw these on a piece of grid paper with a protractor and scale it, you can just measure. That'd be quite easy. Okay. So that's the final, what we call the resultant vector, the final vector. Okay. So the ball will go in that direction. Okay, and we have to work out what force actually is. As I said, we have to measure the angle. We measure the length. Okay, it's probably easier than doing cosine rule, and I'm not going to try to teach it. Now, remember, all vectors have 2 things about them. Remember, a scalar has only size, and the size word, the S word, means what's the M word? Magnitude. Yeah, magnitude is the same as size, but a vector has direction, and you have to give it somehow that direction meaning. If you like true bearings. Oh, come on, they're true bearings freaks of ours. Okay, or you can do this one here, you can say north, something degrees east or west or whatever. Okay, it's up to you. Okay, and what's going on again? Good. So when acting vectors, these are your notes. You have to choose one of the vectors to be your starting vector. Okay? When you add anything together in mathematics, it doesn't matter if it's a vector or a scalar, you have to realise that addition is what we call commutative and associative. Okay, commutative means if I add 5 plus 2, is that the same as 2 plus 5? Is 5 plus 2, everyone, same as 2 plus 5? Yes. Addition can always be added in either direction. So it doesn't matter which of the vectors that you do, because addition is always the same if you add 2 things together. Subtraction is not, though. You have to choose one to be a start, which is selecting. The second thing that you must have to do, okay, after you've chosen that vector, is you have to arrange the vectors so that they lay end to end. This actually means you physically need to draw or move the vectors on the page. Okay? And it's end to end. An arrow, 2 arrowheads must not come together and 2 arrow tails must not come together. It's arrowhead to next arrow tail. Okay. After you've done that, you just simply draw the resultant vector, here's that word, resultant vector, by drawing the arrow from the starting point, the beginning of the formation, to the last tip of the last arrow, the finish. Start to end. Okay? You always say start to end, from beginning to end. You don't say from end to beginning. Okay? It just doesn't make sense. Okay? And finally, we need to be able to determine the size of those vectors. So you could do one of 2 options. If you've drawn the vectors to scale to begin with, then you can use a ruler and a protractor, or you can use trigonometry. Now in this course, we don't want you to use trigonometry much, okay? So most of the time they're going to be at right angles to each other. It's going to be just Pythagoras, okay? But you're still going to have to find the direction by tan or something like that. Maybe at most sine. Okay. So 1, choose a star. 2, form the arrangement and draw the final resultant vector. 3, and then finally determine magnitude and direction. You take a few seconds to pause that. Okay. Right, let's have a look at these 3. We're going to add these 3 vectors together and use the 4 points that we did. What's the first point? What was it? Say it loud so people on YouTube they can hear you. Choose a vector. Thank you, person who didn't exist in this class. Okay. Yes. Yes. Okay. Choose one vector. So we're going to choose one vector. The one vector will be chosen at random is yes, that one there I think it's going to be. Okay. Okay. So let's just stop. But just be careful. What's wrong with this formation? Right, they're all pulling in different directions and the tails are together over here. Now, I want to imagine, the reason why I've drawn this diagram here is imagine you have a car, okay? And this car says, okay, I'm being pulled this direction by that arrow, I'm being pulled this direction by that arrow and pulled in this direction. Which way will the car move if it's free to move? Okay? And we're going to find out which way it's going to happen. So these are the 3 forces and we're going to add them together a single force, an overall force. Just like Mon and Pharaoh were pushing, their forces add together to become a single force. Okay? So we're going to choose, firstly, one of them to be your start vector. I have no idea, I can't remember which one I've just chosen to be the start vector, so let's just, yeah, this one down here, the one that's coming to the bottom. Okay? So let them go to the end. There. Right. So the bottom one down here became the start vector. Now I've arranged all the other arrows end to end to form a single chain of arrows. Are you happy? Does it matter which order I put them in? Could I have started with this arrow and then made a nice chain with the others? Yes, it doesn't matter. The last thing we need to do is say, okay, what is going to be the final result? You just need to work out where the start is and the end is. The start will be down here and the end will be up here. So we now draw an arrow from start to end there. And this yellow or golden coloured arrow is what we call, what's the R word? Resultant vector, the sum, the total vector, the overall vector. That car is going to move in that direction with that amount of force. If these 3 forces pulled on that car, that is going to be replaced by a single force in that direction. All you now need to do, of course, is to determine its length and its direction, and that's best done in this case by scales because I wouldn't possibly do with the trigonometry. Are we okay with that? Okay. Any questions so far? We'll go through each of them as we do it. So we're just going to pause there for 5 seconds and we're going to go into our worksheet. Rightio. Let's fill in the top one, ready to go. A vector quantity is a quantity that has both what and what, everyone? Magnitude and direction. Let's put that in there, okay? The next thing is it can be represented by a what? An arrow. Good. Okay, so it's represented by an arrow, and the length of that arrow represents its magnitude, good, while the direction of the arrow, its skewness on the page, its swivelness is, if that's a word, is its direction. So there we are. Okay. Now I want you to take a few moments to do the following. We'll do one together. Okay. This here has a obviously going to use a ruler to do this. Using one division as half a metre. So let's say that that's a half a metre just there. Okay. You're going to put 4 vectors onto this grid, so just plan where you're going to put them. How would you draw an 8 metre to the left? Right, so it's going to be a line, an arrow. That's 1, 2, 3. I think I've just stuffed up. Let's have a recount. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and which direction is left? That way. So that's 8 metres to the left. Obviously, I did that by hand on the board. You would do that by a ruler. Okay, have I got the left right? Okay, now you're going to be using left, south, and so on. Okay, when you're doing northeast, northeast is a 45-degree angle. We know that. So that's, you can do 45, but here you're going to have to do a 30. So for this one here, you probably don't have a tractor with you. This will be for homework. Okay, could you do B and C now, please, on there? Okay, that's just corrected. The next one was a displacement of 10 south. This requires an arrow to point downward. Okay, so south is another way of drawing that on a page, would be pointing down, and it's going to have 10 units. So you need an arrow that would look like this. And let's just count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, and one little bit short. 10. Okay. So that would be a displacement of, that represents 10 metres south. So remember also, could you please make sure that you write along it. You don't need to say south, you just need to write what it is representing in value 10 metres. Okay. Okay, could you complete the rest of that part of the question for homework? We're going to move on. Okay. So what we're going to do is we're going to copy, or we're going to actually add these two forces together. A force of 10 Newton north will add with a 20 Newton east. So using, whoops, let's get a proper there. There's north is that direction and east is that direction. So we'll just remind ourselves which directions they are going to be. I'm going to draw, remember when we add vectors, does it care which one I add first or put down first? No. So let's do a 10 north. Now in our plan here, how about we make each of these boxes worth 2 in our scale? How's that? Okay. So to do a 10 north, I'm going to do maybe starting here. That's 1, 2, that's 2, 4, I've got to do 5 boxes, so 1, 2. Yeah. Is everyone happy? That's 5 north, 10 north. So that's 1, 2, 3, 4, 5. That represents 10 north. Okay. And now I'm going to put on that a 20 east. So 20 east, I'll put in another colour, put in pink. That's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 20. Okay. Can you see my arrows just in case you can't? They've moved slightly, which is obviously. So there's an arrowhead there, and there's an arrowhead there. Okay. Don't forget to label them. That's the 20 east, so that's 20 newtons east, and this is the 10 Newton north. Okay, these are forces, they're 2 forces acting together. Right, those 2 forces are going to act together, therefore they're going to combine to become one big force. Let's now work out the one big force. I'll draw that in, let's do it in green. Why not green? Okay, where do I push the beginning of the formation? Is it this end up here, or is it this end down here? It's always this end down here, isn't it? So I draw an arrow from here and up to there. Okay? And don't forget to put the arrowhead on the right end. The arrowhead is there. Okay? Okay, now I want you to use, because you've done this by scale, each of these is worth one. Actually, I don't know if it's photocopied. Well, is that exactly a centimetre for you? Okay. It's slightly smaller than a centimetre, is it? Okay. Could you just measure that length there for? Actually, just like that. Just have it. I'll do it quickly, wouldn't it? Okay. So this here would be equal to the square root of 10 squared plus 20 squared. That's probably quicker than actually trying to work it out by scale. Is that okay? That's 100 plus 40, that's 400. 500, square root of 500 would be...
22 point, how many decimal places?
Just one, you're fine.
4.
22.4 units. Excellent. Okay, so this length here is 22.4 newtons. And we now need a direction. Let's work out this angle in here. And the best way of doing that would be by trigonometry. So let's call it theta. Okay. If we want to work out this angle here, then we use these two. Don't use the green one. That's the one that you found. So just in case you're wrong here. To do this, you do opposite over adjacent. Are we okay with that? So tan theta. Use a little bit there to refresh on sine, cos and tan. Are you okay with that? So tan theta would equal opposite, which is 20 over 10, which is 2. So theta would equal shift tan, inverse tan of 2. Can I get a value on shift tan of that? And shift tan of 2. 63. Okay, we'll go to the nearest whole, 60 degrees. 63 degrees, and that means that this here is 63. So we can now refer to it as north, 63 degrees east. Or you could, if you liked as true bearing, you could have said that the force is 22.4 newtons at 0.63 true. If you like true bearing, do true bearing freak. Yeah? Right, yeah. Are you okay with that? Okay. I would like you to circle now B. You're going to do that one. You might not have any room over here, but you can do it in your book or have some grid paper at home or whatever. We should do B for homework now. Okay. I'll give you a few moments just to finalise that first question before I move to the next one. Okay. I also want you to do C for homework as well. So could you please circle C over here? This is a momentum. Now, it doesn't care if you don't know what momentum is. All you now need to know is momentum is a vector. So just treat it like force. And you don't have to know what this Newton seconds is. Whereas force is measured in newtons, momentum is in Newton seconds. You don't need to know. All you need to know is a vector of 60 west is adding to a vector of 20 north. Okay? And there is some room over here for you to do it. Okay. I'm also now going to get rid of that one there. Just put that there. That one then requires a protractor and it's a pain. It's not worth it. It's not worth the effort tonight to try and do that one. So C and E as well, please. There. Okay. Now H. Just moving down to H. Let's scroll down. F, G, and H down here. Also for homework, or in fact, they're going to be happening in a few more moments. Okay, this H one down here is going to have 3 vectors that you need to add together. Okay, so this one here would look something like the following. You'll have a south vector, wasn't it, Roy? A south vector, then a west, and then a north. So you'll have a south, then a west, then a north. Okay. Are you happy with those three? So it looks something like that, and you draw an arrow from the start to the finish, and so on. Okay, so I'll take your questions in 5 seconds. Okay, so your homework so far will be to complete up to H there, but do not do D, please. Okay.